But first, my name's Dietrich. I work on IPFS, Filecoin, and other things at Protocol Labs. I've been here for a couple of years. Before that, I worked on web browsers and operating systems and all kinds of other things at Mozilla. So working on Firefox since about 2006. And I've been in browser world for a really long time, and I'm really excited to bring the decentralized web into that world. So we'll talk about that as well. But first, let's talk about the things that you're going to do at this hackathon. So we've got a few weeks. We've got a whole bunch of people who want to build a whole bunch of things. We want to be able to help you do that with IPFS, P2P, and Filecoin, make it easier to build the decentralized applications that you're here to build. And to start, I'm going to talk about a couple of different things that IPFS can do, the things that people are doing with it. Some of that, you might have seen this in the intro session. A quick summary of what IPFS does, how it works, some of the key characteristics. It addresses things by content instead of location. I'm going to talk to you a bit more in detail about what that means later. It has cryptographic verifiability. This means that you can ensure that what you asked for is actually what you got. And it has transport agnostic peer-to-peer networking. HTTP runs basically over TCP, and now with HTTP3, a little bit of UDP thread in there too. However, IPFS can run over anything, whether it's HTTP itself, TCP, UDP, Bluetooth LE, maybe even NFC, at least to start a peer connection. There's all kinds of opportunities and options there. And it has the ability to create contextual trust models where the HTTP world trust is defined by the intersection of the domain name, the SSL certificate, and the website you requested. With IPFS, it can be determined by you, which is a new and interesting thing that the web today can't do. Some of the problems that addresses the needs of emerging networks that need more resilient networks that don't require round-trip DNS, for example, or persistent connections. Security models that maybe aren't incentivized the right way. Can you really trust anything that has the SSL padlock when anybody can get an SSL certificate? Back in the day, that trust was derived from SSL certificate authorities looking up the addresses and checking the companies were real. So it's not as sure as it was today. You can be sure the transport is encrypted, but that's different than being able to trust the organization. Things like malware, very, very big problem. Broken links, there's even Jonathan Zittrain read an article last week in the Atlantic about how the web is dying. You look at court cases or articles or things that refer to links on the web from 10, 15 years ago, and a lot of those links are dead now. And IPFS aims to really change that and design a web that can last through change. And it doesn't work that way. The web today doesn't work offline, and IPFS is designed to work offline by default. I often describe IPFS as a browser cache, whereas the cache in the web browser is a side effect of you browsing, and HTTP caching headers is like servers being able to tell your computer when to delete its files. IPFS is the other way around. It's a file store of things that you've seen where you get to decide when they are deleted instead of letting remote servers decide when those things are deleted. And it's also very useful as a mitigation tool against some forms of censorship. So being able to access information is really important for large parts of the world. Things like Wikipedia, which seem basic and readily available to some countries, are really problematic and not accessible in some other countries. It's being used as the data store for decentralized naming services like Unstoppable Domains and ENS and Handshake are all services that support IPFS as a way to point a decentralized naming service to your content so you can serve it from anywhere. We've seen it over the last year, really importantly, it being used to share COVID news. So important critical health information, which is not as readily available in some countries as others, you can get over IPFS, and some groups have been doing that. As I mentioned, Wikipedia being served in many languages where the countries may have restricted. Right now, Myanmar is in the midst of massive turmoil, and the government has shut down, not just shut down many websites, but shut down the whole parts of the internet or the entire internet in parts of the day in some places in the country. IPFS can work person to person in these circumstances, and the community there really wanted IPFS, the Wikipedia translation in their language on IPFS. That's something we worked with them to do. If you haven't heard about NFTs lately, then you're not paying attention. Definitely took over our world. IPFS is being used by many NFT systems to be able to host assets and metadata. So huge explosion there, but also companies like Brave and others are using IPFS for their swag store. So it can actually load without you having to do a DNS lookup. Identity is a big deal. Most of our interactions online, if it's not around static content, if we're interacting with other people, involves some way of verifying who you are on either end of that interaction relationship. Microsoft's Ion is one. Fission.codes is taking a fully web-based approach to identity. Ceramic and Textile are a few others that are also using IPFS and IPFS hosted data combined with other systems like DIDs to build identity systems that are decentralized, not owned by a single company, and owned mostly by you with data published on IPFS. DeFi, of course, as soon as DeFi summer hit last year, a lot of these services were using IPFS already, and that has kind of become the default. Even the front ends of some of these services are hosted on IPFS. It's also being used for moving large amounts of data across networks. Netflix was using IPFS to experiment with how to move containers across their global network, which, as you can imagine, is probably quite large. ETHOdyssey is a company that built basically an entire music service where each one of the nodes in the service, whether it's an artist node or a music listener node or an aggregator node, all of that data, each one of those nodes were IPFS nodes, and they used IPFS for both the serving and the distribution of music data, which is really interesting. And then libp2p, which is part of the stack that I will talk about, that IPFS is part of, that IPFS is built on and Filecoin is built on, is also being used to power things like Ethereum too. So an increasing amount of presence in the overall Web3 ecosystem, many companies building on top of IPFS. On our docs website, docs.ipfs.io, you can see a series of case studies. So if you want to dig a little deeper into how businesses are using IPFS as the overall approach that they're taking to build their products and services, you can learn more in this case study series. And as I said, both IPFS and libp2p are powering Filecoin. IPFS is the peer-to-peer content distribution part of our protocol stack. Filecoin is the incentive layer for being able to keep IPFS data on IPFS and other places for long periods of time. I'll talk about some of the amazing new tools that are coming out to make it very easy to be able to use these systems in a bit. Filecoin Ignite happened last fall. Over 100 projects building on IPFS in Filecoin Ignite and many other projects besides. We've been doing hackathons all this year. I think this is hackathon number 11 or 12 for us. And I think we're going to be doing around 10 just in July alone, sourcing loads and loads of projects building on IPFS and Filecoin. I'm going to talk for a quick second about browsers. So one of the ways that we get to the decentralized web right now is through web browsers. However, web browsers are almost entirely centralized in the way that they only support HTTP. So you can't actually make a truly decentralized request from the network layer of a regular web browser. You have to request HTTP URL, because that's the only kind typically that is supported, except in a few cases, which we are working on very closely with companies like Opera. They now have a IPFS support in Opera iOS, Opera Android, and Opera Desktop. What this does, you can use an IPFS:// URL in the address bar, followed by IPFS content ID, and the browser will resolve that through a remote gateway that we run. Called dweb.link, and these are gateways that can open up anything from the IPFS network over HTTP. So it gives some form of IPFS support inside the browser that makes it easier to build these types and distribute these types of websites. We're working with Ayala, which if you haven't heard of them, they are a web consultancy that has commit privileges and have worked deeply in all of the web browser communities. So they can commit to WebKit, to Chromium, and to Gecko, and they work with W3C and ATF and with us to be able to make the fixes that we need to be able to have Web3 products and services and technologies work better in regular web browsers. If you look at the IPFS blog, there's a very long post from them about the work that they've done. Working on the actual web platform itself, I can tell you from long experience, is a slow, arduous, and very you have to be very careful in that process. So it's really a pleasure for us to work with a company like Ayala, who understands the space very well and can make the little changes here and there on the web that we need over a long period of time, working with all of those browser maker stakeholders. We have been working with Brave very closely over the last couple of years. And as of earlier this year, we actually hit a major milestone where Brave now supports IPFS natively. You can actually start a full IPFS node from within Brave. So if you open up an IPFS URL or Brave detects that the website that you're looking at is available in IPFS, it'll ask you, do you want to open this in IPFS? And you can say yes, and it will download and install and run a full IPFS node for you. So we are making progress in browser land. We are also working on the rest of this year on deeper integration into Chromium so that all Chromium-based browsers can use IPFS more easily, which should be very exciting. So let's talk a little bit about what IPFS is and how it works. HTTP, all the browsers make a request to one server, or sometimes one address anyway. There might be thousands of servers behind it, but you only make that request to one place, which that one place is that centralization choke point for the availability of that data. IPFS works peer-to-peer. In HTTP, if that server in the middle goes down, you cannot access the data anymore, or isn't available, or your internet goes down, or your DNS goes down because your country shut it off. With IPFS, some chunks of the network can go down, but if people still have content and are serving it, it can still work. Addresses look a little bit different. In a regular domain name with HTTP, you have the HTTP scheme, which is the protocol, the domain name, which you make a lookup through the DNS system, and then you have followed by a path, typically to some files that you're asking for. IPFS, every single one of those files has a unique ID that is generated by its contents. So that's a content address. And you request things from the network through that address instead of through a domain name. The address itself is made by hashing that contents. You can tweak a couple of things in these addresses, which hashing algorithm you want to use, so several other factors, but ultimately comes out looking very different than HTTP URL, and a IPFS content address is a URI that represents just that data. If you change even one pixel in that photo that you uploaded to IPFS, it will have a different address. You can also think of that as a built-in versioning system as well. One thing that is different about IPFS than HTTP is that files that you add are immediately chunked into many, many pieces. So those pieces individually can live in different parts of networks, which adds another layer of resilience to the system. So when you make a request in HTTP, there's a whole bunch of computers out there. They all might have the data you're looking for, but you can only ask one, and you can only get that data from one. IPFS, you can ask for that data, and sure, that one publisher may have published it, but anybody who has it can reply. And because of the cryptographic verifiability of that data built into the protocol by its address, you can trust that when you get it back from those other computers, that it is the same thing that you asked for and that the original publisher would have returned. If that publisher goes down or is no longer available or is offline for some reason, they forgot to renew their SSL certificate, or they got bought by Twitter and shut down, or the country shut off the DNS, makes it not available to them, or shut off the entire internet, but your neighbor next door has it and you are within Bluetooth reach of them, or you have the same Wi-Fi subnet, all of that content is still available. So this is one of the major differences that IPFS has in regards to, in contrast to HTTP, which is that no matter where that data is, if someone is reachable by you and they have it, they can serve it and you can read it. And the same goes for you to them. You can serve the data that you have to other people who might be asking for it. So IPFS is part of a larger stack, and Filecoin, which builds on top of all of these things. IPFS builds on top of IPLD, which is the way that we link data. When I talked about how we chunk a file up into many pieces, we use IPLD to create a graph of all those pieces. The transport layer is libp2p, which has many different transports that it can use underneath it and allows us to not be dependent on a centralized network resource. And multi-formats are a way of building things like the IPFS content addresses, also used in Filecoin. And these addresses are future-proof and upgradable, which is very different than HTTP addresses, which are singular, centralized, and fragile. That stack is used for applications. IPNS, IPLD are used for naming and building those graphs of data. And then libp2p does the routing, builds the network, connects computers. The IPFS node itself does a number of different things. You can spin one up and run it persistently on a server. You can run one on your local desktop computer. We'll talk through that shortly. And you can even have them transiently. So a project called Bertie has made Go Mobile IPFS, which is a full IPFS node that runs in mobile apps. They have Kotlin and Swift bindings. You can use it on iOS or Android. And it spins up a node very quickly. It has a set of characteristics from the configuration standpoint that make the node as non-battery sucking as possible. So you can imagine running an IPFS node can take up some battery lifetime. So designing for mobile is about balancing that resources against the user need and what the user wants to do. So they've made that work, which was pretty amazing. Those nodes can be transient or persistent. They do a bunch of things. They manage your identity with keys. They sync data in coordination with other peers on the network. They link things even across nodes or across the network, and they can run and serve the Dapps that you are building, like you're going to build in this event. There's a number of different IPFS tools and services that you can use. The easiest way to probably get started for you all is to download and install IPFS Desktop. Yeah, this runs on Mac, Linux, and Windows, and you can run an IPFS node. It will show you a bunch of things like the files that you have, who you're connected to, how much data you're serving, how much you pulled down, and has a list of all the files and folders that you've imported. You know, it looks kind of familiar. It's a file list. You add things into your IPFS repository. You can manage those things there. I'll show you some statistics about all of those things. It also installs the IPFS CLI. So installing IPFS Desktop is an easy way to be able to have a tray application that shows you the status of your node, how much data you have, be able to quickly add things, and also installs the CLI in case you want to build applications there. The CLI, IPFS CLI is responsible for the entire life cycle of managing an IPFS node. It has loads and loads and loads and loads and loads of different arguments and commands that it can take. You can install it through many of your favorite package management systems. It's available for a number of systems. And if you go to the IPFS docs website, docs.ipfs.io, you will see all of the ways that you can download it and all the operating systems that are currently supported. IPFS init will init your repo on the command line. IPFS daemon starts that node up, tells you what address it's listening on. You can add data with the IPFS add command. Very intuitive. It adds data into your data store, but also immediately publishes the availability of that data to the network. It returns the address, the content address of that data. You can use the IPFS CLI to get information from the network if you have an address that you want to request, or cat it so you can pipe it into other applications. You can use the IPFS stats command in a number of different ways to learn about the node itself, what it's doing, who it's transferring with, whatnot. You can also do things where IPFS by default will just ask the global network via the Kademli algorithm and DHT about who has what, or telling people what it has. But sometimes you need to connect directly to a node. Let's say you have another node that you want to replicate a set of data. You can use the IPFS swarm connect command to connect directly to it. You can set up your nodes. Let's say you have a group of nodes that you want to always connect to and be able to persist and share data. You can do that in the IPFS configuration file, where in the peers section, which will basically do the same thing as IPFS Swarm Connect, but it'll do it to any address you list there every time you start the daemon. You won't always have access to IPFS. IPFS URLs are not supported everywhere yet. The IPFS gateways allow HTTP access to data on the IPFS network. There are a number of different IPFS gateways. We run a few different ones with different features. Cloudflare runs a really big one. A bunch of the IPFS pinning services that I'll talk about in a few, like Pinata and Textile, also run IPFS gateways. And there's also the IPFS public gateway checker, which you can look at, which shows a bunch of different gateways and which features they support. Since browsers don't fully support IPFS, you can add some IPFS features to browsers with the IPFS companion extension. This runs in Chromium-based browsers and also Firefox, and allows a bunch of different interesting things like easily supporting IPNS and ENS inside browsers, and allows you to do things like access your IPFS local node from web applications. And so that's a powerful way to be able to build and test applications against an IPFS node. JS-IPFS is the JavaScript implementation of IPFS. It's great for building JavaScript applications. It doesn't completely implement the entire IPFS protocol, so it does need to connect to other IPFS nodes in order to communicate effectively with the broader network. But you can install this from NPM and build it into your applications, both node server-side applications in Node.js, but also in browsers. And JS-IPFS will compile into browsers. There's also a version of it that if you have a very high performance application, you're moving lots of data and doing lots of client-side work, that does run on a worker thread. So it doesn't sit in the main content process of your UI. So it's more memory and power efficient. If you're, say, running IPFS on every single one of the pages of your application, you have maybe a bunch of tabs open, this can be very far more performant. With every application and protocol, there are the ways to build things with it that make it easier. These are some of the toolkits and frameworks that make it easier to build with IPFS. Not all app developers work with the guts of HTTP every day. This is the same thing is true of IPFS. As you're building your applications, you probably won't work with most of the guts of IPFS or the lower level plumbing in IPFS all the time. You just want to make your application and move on with your day and distribute it on the decentralized web. So things like Textile, 3box, OrbitDB are different frameworks for building applications with IPFS that make it easier to connect with multiple users, to collaborate, to sync or stream data. OrbitDB as a object database abstraction layer that's built on top of IPFS, great for working with dynamic data. Textile and 3box both have different identity solutions and also ways that allow you to encrypt data so you can have private data on the IPFS network. You don't want to share everything all the time. And the IPFS public network is, as the name implies, public. Domain name resolution. So if you want, you can use DNS link, which is a way to link traditional DNS names to IPFS assets and on the network, addresses on the network. Stoppable domains, ENS, and Handshake all support IPFS, where you can point one of those names at an IPFS content address, and then it will load it up, make it easier to work with for your end users. But one of the questions, especially when talking to groups like this, people ask is, where is my node? If I'm running my node on IPFS desktop and I'm just running it on my computer and I shut my computer down, what happens to my applications? What happens to my data? Well, as you can expect, it doesn't stay online magically. You have to keep that data up. Similar to in the regular web, when you make a website, you have to pay somebody or use a service or run your own persistent server that you know is going to stay up all the time to be able to keep your data online. Same is true of IPFS and Filecoin. Many people seem to have this idea that IPFS magically keeps data online forever. Now, that is not true. However, there is some magic sometimes. If a bunch of people are hosting your data, you might have a whole bunch of people hosting your data, and that's great. So for example, let's say your website is very popular with Brave users that have their IPFS node enabled. By default, the Brave implementation of IPFS will host up to 1 gig of data. So for some time, a bunch of those users might be hosting your data for you. You get some organic support and resilience in the network. That is fantastic, but it's also not a guarantee. And that's a big difference when making sure that your applications stay online. It's not going to happen magically, but you might get some help. In the HTTP world, you can't get any help. But in the IPFS world, you can get some help, but it's also not a guarantee. So you need to make sure that your application data is posted or pinned on a service that is keeping that data alive, while other people might also keep it alive, which is an extra benefit of the system. Some people use a lot of names that might seem familiar on the centralized web to be able to keep your data decentralized, which seems counterintuitive, but is very effective in having your data in redundant places. The pinning services specific to IPFS, some of them term them Infura and Pinata. These are all services that you can pay to keep your data up. Some, like Pinata, have a free tier where you can keep up to a certain amount of gigabytes for free pinned on their system. So worth trying out. Most of these have HTTP APIs to be able to manage your data using the tools that you're familiar with as well. Fleek is one that a service that has shown up that integrates more deeply into how you build regular websites. So it supports things like your GitHub or GitLab automation, Bitbucket. You have ways to be able to hook into the CI and CD, so you can deploy your site automatically the way that you're used to on the regular web. So it makes it very easy to transition to Web3, but also have your website hosted on the regular web and the decentralized web at the same time. Filecoin pinning services are a way of ensuring your data is there. Even let's say you want to have a backup where your computer is not the sole place where you have that data, or you want even just your data pulled directly into places like Fleek or some of these other pinning services from Filecoin. You can use a Filecoin pinning service. So Fleek does integrate Filecoin pinning service in their service called Space Daemon. They have your IPFS, your data hosted on IPFS and Filecoin. Textile built PowerGate, which is a Filecoin node and IPFS node put together into a wondrous singular service that you can use of theirs. A new one that is being worked on by a group of protocol labs called the Applications Research Group is called Estuary. Estuary is a way of hosting your data on IPFS and publish and store it on the Filecoin network in a way that really, Filecoin has a concept of deals where it manages those deals for you and works with the Filecoin storage providers on your behalf to make it easy. They let you see things like this, the aggregate data from your deals that you have. So that this means that your data can be stored across a wide number of providers, where in the regular web today, you would say, make one deal with Amazon, or one deal with Azure, or one deal with Dropbox. In the Filecoin world, you can have deals with many different people, with many different storage providers. You will get really, really good prices, a lot of times even free with a program called Filecoin Plus. You get basically free credits from storage providers that are earning Filecoin, so they earn money by hosting your data for free. I know it sounds counterintuitive, but it really works out pretty well for them, and it works out well for you too. So it's worth checking out Estuary and all these Filecoin services that are coming up. But even with some of these services, it's the Web3 world, the transition is still complicated. There's a lot of different parts. The topology of the regular web is a little less complicated. Like I said, you make one deal with one provider, and the decentralization doesn't come for free. You may have multiple relationships with multiple nodes, and your data might be in multiple different places, and then a group of strangers might be serving it. That's awesome, but even who are they, and are they online all the time? It seems a little complicated. So there are a number of different services and ways that we're trying to help make this transition easier. I think as building your applications for this hackathon, these services might come in handy. And Protoschool is the first one that I wanted to tell you about. Protoschool is a website, proto.school, that has a set of interactive tutorials. So maybe you've used IPFS even a couple of times, but how does it actually work? This is a set of tutorials that you can go through, and it even has some inline coding if you want to do that, to learn about the primitives of these systems, the basics of P2P transports, the basics of IPFS content addressing, how those addresses are built, the underlying cryptographic formats, what makes it safe and secure, many things that you can learn on proto.school. Something we launched recently with the rise of NFTs is NFT School. We noticed that many people were coming to our channels asking for help with NFTs. Some of them even new to Web 2, but then having to also learn Web 3 on top of it. So we wrote NFT School, which is a place where you can learn about how NFTs work, how content addressing works, how to make sure that your NFT assets and metadata persist alive on the distributed web and the regular web. It's got a set of tutorials, and it also shows you how to use this service, which we launched earlier this year, NFT.storage. You can go there, and it is a free service that will host your NFT data for as long as we exist as an organization. It also backs that up to Filecoin, so Filecoin providers are paid way down our human timeline, hosting that NFT data to be able to make sure that it stays up for a very long time. So this is a service that will, if you are building NFTs at this hackathon, definitely check out NFT.storage, because it will make it much easier for you to be able to get your applications working quickly and easily, and provides free storage from us using IPFS and Filecoin. Slate is another service that makes it very easy to build beautiful end user applications. You can create a Slate account, get an API key, and upload data, files, photos up to the service. You can build applications using the API that it provides, which makes it a little easier for you as you're onboarding into the IPFS and Filecoin distributed web to build the type of applications in the way that you're used to with an HTTP API, but ensuring that that data is available on the distributed web. Much easier, maybe as a starting point, if this is your first time in this hackathon building these types of applications. We want to be able to make sure that the advanced people can use the lower level APIs. People who are new to the space have ways that make it easier to onboard, where HTTP is going to be the air that we breathe for quite some time in the developer world. So having APIs that support the regular web as a way to get onto the distributed web is very, very important, especially for new people who are learning about this and building these applications for the first time. So we are super excited to be here for this event. We're very happy to work with you all. As Denver said, we have a bunch of bounties. We have, I think, $5,000 worth of Filecoin in the bounty for this event. And we have 2 particular bounties that you can earn for, which are using NFT.storage in your application. Give a prize for that. Using slate.host, which I just showed you. Also, prize for that. So please come. I will join the ETHOdyssey Discord, hang out with you all. Maybe I'll see you in the metaverse rooms as well, so we can feel like it's real. And if you have any questions, we are here to help. We also have an IPFS Discord. I'll share these links in the ETHOdyssey Discord. Feel free to ask any questions. We'll have people hanging out in these channels through the duration of the event to assist you as you're building your hackathon applications, hopefully with IPFS and Filecoin. Thanks for having me today. Let me check the channel, see if there are any questions there.
Yeah, thanks for that, Dietrich. Yeah, really cool stuff.
Right,
the NFT school is really excited to check that out myself too.
Yeah, we're really hoping. We realized so many people were coming to our channels asking how this stuff worked. Even the R NFT subreddit has a Discord, so I hang out in their channel, and it's just so many people that need help trying to figure out how these NFT things work. So I've been spending a bunch of time answering questions in that channel and pointing them to resources like this. Like here, there are the resources there. We can help you learn about this stuff. But can you imagine being a new Web2 developer that's also trying to learn about Web3, or somebody just came out of a boot camp and then the boot camp didn't teach you anything about Web3, only Web2? So we're trying to make it easier for people.
Yeah, I'm sure they'll appreciate it. And I think we have some questions split between the chat and the Q&A.
Cool. I see this first one. So IPFS nodes are connected in mesh network kind of structure, each node connected to every other node. Yes, for the first part, they are connected in what's called a distributed hash table. So that is one connected virtual network that's an overlay of connections on a regular hardware network of wires and cables in the same ways that we connect regularly. That overlay, the DHT, is not, those nodes are not connected to every other node. The DHT is powered by an algorithm called Kademlia that allows you to efficiently connect to the fewest number of nodes in that network that you have to, in a way that propagates the message as efficiently performant as can be. There are many different ways of building these types of overlays. A DHT is one of them, and Kademlia is only one of the algorithms that can power a DHT, but that's the default for IPFS today. So the idea is, what is the smallest number of nodes that I have to connect to be able to propagate my messages across the network in the shortest and most performant period of time? And it's a very interesting area of research, and it's been around for a long, long time, but still being researched and built on and grown today. How can we use Filecoin and IPFS together? I finished my talk with a couple of things that did exactly that. So check out PowerGate, check out Fleek's Space and Space Daemon, and check out estuary.tech. These are 3 different places that allow you to publish and archive to Filecoin and be able to retrieve your data from IPFS in one service. We're going to see a lot more things like this now that Filecoin launched last fall. we're starting to see more and more services like this where it's much easier to use both. Can you discuss basic attention token scope and what it is? I work a lot with Brave. Actually, I know some of the Brave people from way back in Mozilla days, back in the olden days, so we hang out and talk a lot. I am not a BAT expert. I am very interested in working with them now that we have IPFS inside Brave to be able to do some things like how can BAT and Filecoin play together? What if you could tip in BAT, but that tip converted into Filecoin that made sure that the assets of the website were hosted for a long time? What if you could tip storage? So I think there's lots of ways that we can play with BAT and Filecoin and how they, the integration of IPFS into Brave do interesting things. I think we're very at the beginning of these types of relationships, right? Whereas Ethereum, you have things like wrapped tokens. In some of these other contexts and application runtimes, things aren't nearly as mature yet. Things are still kind of like standalone and separate. I think over time, we're going to see as browsers start to integrate, like first browsers bolted on wallets, right? Just bolt a wallet on. MetaMask is an extension. It's a fantastic extension, but it's not integrated into the browsing experience. I think we're going to start to see more of that. And we're going to see the browser world and the Web3 world collide. The streams are going to cross, and it's going to be really fun, I think. Can IPFS host multiple web pages? Oh yeah, absolutely. So think about it this way. If you upload 5 files to IPFS, each one of those things is an individual file that you can address on the network, same as HTTP. If each one of those 5 files is an HTML page, that's 5 web pages. So you can host as many pages as you want. You can also have as many of these decentralized naming services that you want point to different IPFS files that you've published. So yes, you can host as many websites as you want. Examples of storing IPFS on IPFS as compared to on the Ethereum blockchain. Actually, IPFS doesn't have a blockchain. And you can go to one of my favorite websites, does IPFS have a blockchain.com, to find out the answer to that. But blockchains love IPFS because the immutability of that addressing makes it much safer to write an IPFS address to a blockchain than it is to write an HTTP URL. Like I said before, what if you forget to renew the SSL certificate? Or what if your company gets bought? Or link rot is a real problem. When you're writing URLs to an immutable log or an immutable ledger, that means that data, the link to that data is fragile. If that one website goes down, that link will break in that DApp, even if millions of other people are holding that same data. So blockchains love IPFS. IPFS does not have a blockchain, but we work with a lot of blockchains because they use us pretty heavily. Oh, and that question was actually about the expense of storing on IPFS. So actually, that's another one of the reasons storing lots of data on the blockchain can be very expensive. So, or storing on IPFS can be very inexpensive and a lot of times free. So you can store your data on IPFS, get the IPFS address, and in your DApp, write that address to the blockchain instead of writing the actual data to the blockchain. This is called off-chain storage. And it's a very common and popular pattern because it saves you so much money because blockchains can be expensive. I have a question, how do IPFS record history and content changes, for example, a doc, is there then something that's changed, how to track the changes in the content or doesn't? That's a great question. So how do you do dynamic data in IPFS? One of the most common ways that people do this is using the IPNS system, the interplanetary naming system. So imagine you publish a file to IPFS. It has an address. If you change even a single pixel in that file, that address is going to change, right? And it's going to be a new version. IPNS allows you to publish a record that points to an IPFS address. And when you publish the new version, you can update IPNS to point to that new IPFS address. So every time it changes, the content changes, you update the IPNS address to point to the new version. So that's typically the way that dynamic, like if you're going to publish a blog, if you're going to publish an RSS feed, if you're going to publish anything that changes a lot, you would use IPNS as a pointer to that data. That's actually how a lot of these other services, like when you publish with Fleek or when you publish with ENS or Unstoppable Domains, if you publish a new version of your website and you update the Unstoppable Domains record, that's basically what it's doing. It's saying, hey, there's a new address for this data. And you tell the naming record, here's where the new address is. Pretty simple. It's a little bit different than traditional systems where you're actually just changing the same file in the same place. Here, you actually have a discrete version change every time. Can IPFS be called a decentralized app or not? IPFS is actually a decentralized protocol that decentralized apps can run on. The reason why they're decentralized is because the app is running on IPFS, which is itself decentralized. So I don't know that IPFS itself is an app. It's more like a protocol that runs apps. It can run as many apps as you want. It can run everyone's apps. You can even run other people's apps. Even if that company goes away and you have a copy of that app, the app will keep running for as long as you have it and you want it to keep running, which is really different from a power that you have as a user. In the web today, websites turn off. Like oh, Facebook bought us, we're shutting it off, right? But you're like, but I use that every day and I like the old version. And I know the Facebook version is going to suck. So now with IPFS, if you have an app that runs that way, you have a copy of that data, that app can still work, which is a really powerful thing for end users. Can IPFS, how does it differ from BitTorrent? BitTorrent has a radically different type of, one, it doesn't have content addressing. And two, it has a very different type of way of distributing the data. There are some similarities in how the P2P aspect of the transport works, but BitTorrent doesn't have anything like Filecoin. It doesn't have anything like IPLD. It doesn't have anything like content addressing at all. So the data model for IPFS, very, very different from BitTorrent. Can IPFS be trusted with sensitive data? You can encrypt data and then publish that to IPFS. IPFS by default is a public network. So it depends on how sensitive your use case is. In this type of question, when we're building applications for other people, we construct what's called a threat model. So sensitivity is defined by the level of threat that you have against you. If you are operating underground as an activist in a country where your government is hunting you, you want to have a very, very different threat model than the default that IPFS is. IPFS by default is a public network. Its goal primarily was to make sure that data stays available. It doesn't make you immediately unfindable. It doesn't mean you can publish anything without the repercussions that come along with what you published. However, in some circumstances, you can, if you're not worried about seeing your people seeing your actual activity, but not see the data, you can publish encrypted data to the network. That's what things like Textile allow you to do. So it really depends on your situation. How sensitive is that sensitive data? If it's encrypted, you're generally probably fine, but it really depends on what the level of threat against you is in that situation. Is it possible to, did I miss one? Is it possible to establish a WebSocket like live connection so as to make a chat app or store the chat data in IPFS? Yes, it is. There are loads of different IPFS. If you just really like look up on DuckDuckGo IPFS chat app, you'll find a bunch of different examples that are pretty easy to copy. In the JS IPFS repo, we even have an example that's there to copy. It's super easy to run. A lot of people actually like, so if you look at the IPFS blog, we recently published a post about browser connectivity in IPFS. And that used WebSockets. It showed you how to use WebSockets and WebRTC. So you use a WebSocket to initially make a connection. Once you make that connection, you can use WebRTC to connect to other peers. So it's a way to be able to have IPFS-powered websites where the front end might be loaded, centralized, but then actually can be decentralized at the data layer. So every time we changes, if we're using a pinning service, we need to first unpin the earlier version and then pin the new one and point to that one. Yes, that's exactly how it works under the covers. However, most of these are completely automated, right? So like if you upload new versions, that's why Fleek's tools are very powerful. It basically, Fleek kind of works like Netlify does. Like you can auto-publish through a GitHub action or anything like that, and your website's just updated. Under the covers, yes, you basically are not, you're not unpinning, you're just changing the pointer. So IPNS is a pointer maybe to multiple sets of pinned data. So you're just changing which address your pointer is pointing to. But you're not necessarily unpinning that data. You can keep that data pinned for as long as you want. You still might want that data available for the people that want access to it, right? So there's no need to unpin. The dynamic data aspect of it is just where the pointer is pointing to. IPFS is also used for storage of Filecoin isolate. What's the difference between them? Is Filecoin also provides with the hash value? Yes, Filecoin addresses are IPFS addresses. Same. Filecoin uses IPFS for that reason. And if you save to Filecoin, it is available on IPFS. So this makes it very easy for you to be able to address that data. It's going to be easier and easier to be able to address that data quickly as we have what are called retrieval markets that are coming soon, ways that basically bidders can bid for the lowest possible retrieval cost. If you've ever published a very large and popular application on Amazon S3, you will be very familiar with things like egress costs. So we want to have open markets for being able to retrieve data and get it to the right places fastest. That's going to be the next major phase, I think, of Filecoin data availability. Filecoin allows you to pay a miner or a storage provider. They're not really mining anything. They're just storing your data for you and proving they still have it. To pay a storage provider to host your data and make sure that it stays available. That's the difference between IPFS and Filecoin. Is IPFS, you can participate in the network, you can host data, but there's no way you can't say pay somebody on IPFS to host your data. So you pay Filecoin to be able to have somebody keep your data available. I'm excited to note we can host backend server with IPFS. Yeah, so IPFS itself is a server. So if you run an IPFS node, you can access the data directly through that, through the IPFS network or through HTTP gateways. So yes, absolutely, it's a backend server in many different ways. We see a lot of people too build hybrid applications. Well, they'll build an application that is an IPFS node and other components and parts. So think about it like how would you build a backend application with MongoDB? Right, you'd have maybe some Node code or some Python code or some Java code or some whatever you're developing with. Also, a separate service that runs a daemon, like MySQL or MongoDB or IPFS. It runs as a service alongside your applications, or you can use things standalone if you're developing entirely front end. How IPFS deals with data piracy. Oh, so yeah, so that's a really difficult question, right? Right now, you can publish anything that you want to IPFS the same way that you can with the regular web. However, with IPFS, the network is completely public, so people can see who you are if you are publishing that data. If you are publishing illegal data, you are eminently findable as the person serving that data. So the regulations with privacy are really the same as the jurisdiction that you are serving in now. And it doesn't matter if you're publishing if you're pirating data, posting pirated data on IPFS or HTTP or anything else, you are always subject to the regulations of the jurisdiction that you live in with regards to piracy. Can we host the backend server on IPFS? Yeah. So that's kind of like the question that I answered earlier, which is you can run IPFS as a node where you can host your code there. You can run it alongside your server-side application logic. However, one of the unique parts about Web3 is that the logic that you would typically host in your backend is oftentimes in a smart contract. So it's actually running on a blockchain or public network. So it's very different than the type of application architecture that we think of today in Web 2 when we think of front end and back end. Because the front end, one, will typically have more logic and it's portable. The front end doesn't care what back end it comes from anymore. And that's a really big change in how you build applications compared to the Web 2. So I think that my answer to that question would be more like, how do you reframe your thinking around where logic lives? If your business logic and your application logic can all live on the front end, you don't need as much of a back end anymore. And some of those parts of your back end, which in Web 2 are maybe you connecting to a payment service like Stripe or a payment provider or something like that, which is a public, a private service. In Web 3, instead of doing that, you actually have a smart contract where people's wallet connects to that smart contract, which then unlocks some data somewhere else. So it's a very different type of architecture. Instead of front end, back end, you have a multi-party architecture that runs partially on a private network or a public network instead of what was typically a private network before. Hopefully that answers your questions. Is there anything else in the chat?
Yeah. Some other questions in chat, I think.
Is it recommended to store large blob files and gigs on IPFS instead of a centralized server like S3? So it depends on your use case. One of the benefits of IPFS is that chunking I said before. So when you add a 1 gig file to S3, it's a 1 gig file in S3. When you add a 1 gig file to your IPFS node and then you share that address with people, if other people also load that 1 gig file, maybe even only part of it, they can still serve just that part. So immediately it takes that 1 gig file, busts it up into many different blocks. IPFS transport happens at the block level, not at the file level. So if I have that 1 gig file, Denver downloads half of it, but then somebody else asks for it, they can get the blocks from me, they can get half of the blocks from Denver, which immediately takes some of that load off, where in that you would be paying Amazon all of the cost for anybody asking for the file once. Now you have two people ask for the file. Now you have to pay Amazon twice. 3 people. Now you have to pay Amazon 3 times. With IPFS, you get that organic benefit where the people that have downloaded it can also share it. So that defrays some of the cost, but also increases the resilience of that. Because if you can't pay your Amazon bill, Denver can still share the bits that he has, right? So is resilient in multiple ways, is cost saving in multiple ways. So yes, I think it is recommended. There are maybe some things that you would have to do to be able to manage many, many gigabytes. Like you might have to write some automation code to be able to keep those blocks pinned and things like that. But yes, people use it for very large data. Does each node have an IPv4 like address? Yeah, absolutely. So it depends on how you configure your IPFS node. You can, by default, when you start the IPFS node, yes, it has a IPv4 address. How can we ensure piracy does not happen on file stored on this? You can't. The same way that you can't with HTTP. Most piracy today happens on HTTP. You cannot prevent that in today's world, and you cannot prevent that in the decentralized world either. What you can do is you can see on the network who's serving it. So in the HTTP world, somebody can make a website called Your Stolen Files. If you don't know about that website, how would you know who that it even exists? Your stuff might be being pirated. You would have no idea. But in IPFS, you can actually see who's sharing these files. So it's called this IPFS DHT find provs command, and then you pass a CID to it, and it'll tell you all the nodes in the network that are sharing that data. So if anything, it's a little easier to find out who is pirating your data on IPFS if you don't want it pirated. But also the nature of the network is different. It's designed to be able to make data available. You use IPFS because you want to ensure the availability of data. But if you don't want that data on IPFS, it is a lot easier actually to find out who is sharing it than it would be with HTTP, where you might not ever even know. The unique signature of files allows findability in really interesting and different ways. Can IPFS prevent storage whales from storing large amounts of data, effectively giving them control over large amounts of data? This is an interesting question. Storage whales. So I guess my question, I would love to have a use case where that's a bad thing, right? Maybe there's fake news and somebody is ensuring that's available most of the time, but you don't need a storage whale. You just need one node to keep that data up, right? So I don't know about the concept of storage whales, because it's not like you can have, by having more copies of the data on the network, that you get more control over it. Maybe it keeps it more up for longer. If you don't want that data up, then that's not really a storage whale situation. But if it's not illegal to have that data up, then it's like, say somebody is wrong on the internet, right? Like yes, people have data you don't like on the internet, and that's not something you get to control. People disagree with me liking IPFS. Doesn't mean I have to not like IPFS, no. But storage whales doesn't really make sense, I think, in the context of how this works, because you can't, you only need one node, I guess, to be a storage whale. To keep something up forever, you just need one node. So the whale metaphor doesn't really work. Can large cloud providers sabotage network by storing large amounts of data, effectively creating a single point of failure? I mean, you could, so the thing with IPFS is that the network is segmentable. So you could try to saturate one link by hosting a lot of data, or maybe publishing loads of addresses in the network, but not all nodes. The nature of the Kademli algorithm, protections against this are pretty much built in. So it would be very difficult to do that. You might be able to maybe saturate a certain chunk or segment of the network, but it really wouldn't last long. Like the dynamic routing of the network means that you can still get access to the data you need. At that point, you're gonna have more problems with your local ISP, and they're going to show up and give you a problem. It's not going to be a problem for the IPFS network nearly as much. Your bandwidth bill might be a problem as well. Continue the question related to storing large blob files. It's guaranteed that for serving, all the chunks will have been downloaded to at least no node. No, it is not guaranteed. And this is really why I talked about pinning services earlier. If you want to guarantee the availability of data, it's your job to pin it somewhere and make sure that somewhere is available 24 hours a day, all the time. That won't happen magically. Some people might help. So think about it this: you have a base level layer of support in your data by ensuring that you pay somebody to pin it somewhere sometime, or you run your own server that you know is available 24/7. If other people access your data with IPFS nodes and are also serving it, that's like added bonus of resilience, added bonus of reduction in cost, reduction in bandwidth, and increased availability of that data on the network. But it's not guaranteed. Think about it as organic availability or bonus availability. The more popular your thing gets, the more people have it, and the more people are serving it. but you still have to make sure that at least one node has one copy of that data all the time. What if I upload a file, then somebody copies it, and then I delete it? Will I still be traceable? It will only be traceable if somebody is actually logging and storing a historic record of who had what. So once you delete the file from your IPFS node, you're no longer serving it. If somebody asks for the network for it, your node will not say, hey, I have it, because it doesn't have it. So somebody might ask you for it, and your node will say, I won't answer, that doesn't have it. It might be like, hey, go ask these other people. So that record will be not permanent in the network itself, but if somebody was logging everything ever on the IPFS network that they might have it. Like, it would be very difficult to log everything on IPFS network, but you can't really programmatically do that, but you could try. Yeah, Denver.
Hey, Dietrich. Yeah, so yeah, I kind of have the next session coming up in 2 minutes.
All right.
So I think, like we have the Discord and all. I'm sorry to kind of cut you off, but
no worries. Like, these are great questions, and thanks everybody for showing up to the talk. Thanks everybody for joining and asking really good questions. I think it's going to be fun to hack and build with you all at this event, because I can tell that you are all super interested in figuring out how the system works and figuring out what the boundaries of it are and the pros and cons. So thanks for joining. Happy to talk. I will see you in the Discord.
Yeah. Thanks, Dietrich. Always a pleasure to have you. Yeah. Thanks, man. All right, folks, we have the next session starting in 1 minute. I hope you already have the link, so do join in there. That's also going to be a really great session by Patrick from Chainlink. See you there. Bye-bye.